Hi and a very good day. So in this video session, I will explaining the theoretical part regarding Box Jenkins methodology. Okay, so this is actually our final chapter for time series analysis and forecasting, right? Okay, so the content of Box Jenkins methodology, I will divide into 6 parts, which are the first 3 part is the theoretical part of box Jenkins, and then the last 3 parts is the application part where we will model box Jenkins method using R programming. Okay, so in this slide I will explain until the basic model of the box Jenkins method. Okay, right. So the first part is the stages in the box Jenkins methodology, right? Okay, for the purpose of building box Jenkins method, we will divide it into stages, which are in your textbook. We divide the stages of box Jenkins method into 3 main stages. Okay, and the stages are model identification, model estimation and validation, and lastly model application. Okay, so before we begin, it is best for us to see the characteristic of our data series first. Okay, because of what? Because uh, okay, again, the box Jenkins uh, will consider our series to be stationary. Okay, so the stationary we already discussed in the last topic, right? What are the difference between stationary and non stationary series and so on. And before you build the box Jenkins model, or it also known as the ARIMA model, okay, you have to determine whether our series is stationary or not, okay, before we begin to construct the box Jenkins method, right? So the stages, here is the diagram of the stages. As we can see here, it is actually a recursive process. All right, when you model box Jenkins, at the end of it, it's not necessary that your model ends there. Okay, it is actually an recursive process until uh, you get the best model to do the forecasting. Okay, so here this is the first stages, model identification, and then we do model estimation. Okay, we estimate the parameter based on okay, it is actually we will do in sample estimate. Okay, we will estimate the parameter for our box Jenkins model, and then based on this parameter estimation, we will do some diagnostic checking and also statistical tests. Right? What if our uh, okay? What is okay? From here, based on the model identification, we actually will select several model that may represent our time series, and after we select, and then we will estimate the parameter, so that here, as we can see there, okay, we actually have several model, and then this several model will compete with each other. Which model will give us the best um, okay uh, the best model, okay, based on how far our model is different from the actual value. Okay, if it's if this particular test pass, okay, we will apply the model, but if fail, we'll start again and again, right? Okay, so let's take a look at the first stage of box Jenkins method, which is model identification. Okay, here I need you to read this particular point. Okay, it is actually in your textbook, but I understand that some of you might not have textbook. Okay, so uh, I the discussion on the stage or the stage 1 model identification is actually this is the most challenging part. Okay, because of what? Because we determine the model based on some common statistic, mainly by using plot such as autocorrelation plot and autocorrelation coefficient plot. Right? We already introduce you ACF in the last topic. Okay, how can we determine whether our series is stationary or not? By looking at the ACF pattern. Okay, whether it is decaying slowly or maybe okay, and so on. So you have to understand, okay, based on the ACF, okay, we also can determine how what are the model that may appropriate to perform. Okay, and then actually we will run several model. It's not only one model because of what we have is only an observation of at a period of time. Okay, so we determine the model based on that particular model only. But because we say that our series is stationary, it means that the statistical properties of our series will not change it. The although we only check at that period of time. Okay, that's why the concept of stationary is very important in this part. Okay, and then for stage 2 model estimation and diagnosis testing, right, because of we will have several models. Okay, you need to understand that model that fit well at estimation part does not necessarily will give us the best forecast value. Okay, so when we construct this model, okay, you have to understand that there are actually two objectives that we need to achieve. Okay, the first objective is the fitted value should be as close as possible to the actual value. Means that when we calculate the mean square error or residual mean or another uh, another another square error measure such as RMSE, MAPE and so on, we will get the last value. Okay, so that it means that the difference between the actual and the fitted value is minimized. And then uh, the next objective is the model should require the least possible parameter. It means that we need a simple model to explain the characteristic of our time series data. Okay, and here the thing that you need to understand when you do model estimation is what we call it as general fitness of the model. Okay, so we will run several statistic testing to ensure that our time series fits well. Okay, right. So okay, so the first objective is to make sure that the difference between actual and fitted value to be as close as possible. And then the second objective implies only relevant variables need to be included and exclude all 11 variables. Okay, because of what? I will discuss it later when I introduce you the mathematical function of Box-Jenkins method. Okay, right. So next, the last stage of Box-Jenkins method is model application. Okay, after we confirm all the statistical tests, after we confirm the model already fulfill uh, the statistical tests that need to be performed. Okay, we actually ready to use it to forecast whatever things that you need. Okay, and this forecast value can be in terms of a single point forecast, or you may also produce in terms of confident intervals, right? Depending on the nature or the needs of your forecast, you can give, actually sometimes we give both. Okay, single value and also the confident intervals, right? Okay, and again, process of determine the final or best model is actually an iterative way, because sometimes we need to reformulate our series as a new data, uh, as a new data so okay, as we have a new data. Okay, so because of that, we need to develop a system to monitor our forecast value. That's why when we see some report, especially in this COVID-19 events, you see that some report they update their forecast value. Okay, the growth of GDP and so on. They revise the forecast value because to cater, to include this event in the time series data, right? So again, you have to remember, it's not necessary that when you have the best model to forecast, it stop there. Okay, we need a system to monitor our forecast value. Alright, so I think that's all for this video. If you okay, you can read more in textbook or any additional materials. Right, I think that's all. Thank you.